My name is Elio from AT&T's Chief Security Office, specialized in Lawful Intercept, solution delivery for company offered broadband services. Just need a note before the presentation today. To enjoy the topic today, probably we need to get down to some level of details which we will not be able to get down to in the presentation today due to the time constraint, and hopefully the presentation material provides decent level of details just for your offline reading enjoyment. Okay, we've been talking about the IPv4 address exhaust for over a decade. That is foreseeable until it really happened February of this year. The last 5 IPv4 address blocks are handed out to the local RARs from ICANN or INA, and that means the free pool of available IPv4 address has been fully depleted. And this obviously triggers the industry to move to the IPv6 infrastructure in a more proactive way. However, due to...
I won't be able to advance unless I click on this presentation.
Really?
Yeah. Now, look at it there.
So this is good. Okay. However, the migration to IPv6 will not happen overnight, as we all know that, due to the size of the internet and the complexity of the technology involved. Based on our observation, actually there's still very strong business in IPv4. Just in March of this year, we noticed that Microsoft acquired 600,000 IPv4 addresses from Nortel using $6.5 million. And if you do the math there, that's actually $11.25 per each IPv4 address. To give you a perspective there, that's even more costlier than a domain name. So we still see very strong business on IPv4 from that perspective. Plus, some customers will never wish to retire IPv4. Some IPv4 applications or services that are difficult to move to IPv6 may stay in IPv4 indefinitely. What does that mean to us is that we will see IPv4 and v6 will coexist on the internet for a very long period of time. So also referred to as the transition period. What that means to the service provider community is that the service providers should be able to support the interworking of both IP versions. Customers with either IP version should be able to talk to each other as usual. And the focus of this presentation is that, of course, it has an impact on the Lawful Intercept. For a little background over here, Lawful Intercept refers to obtaining the network communication data for the target pursuant to a lawfully authorized orders for the purpose of analysis and evidence collecting. In the U.S., this practice is particularly governed by the 1994 CLIA law, and it's a federal mandate for all the service providers. As part of the data that requires to be reported for Lawful Intercept, there's CACmII, CACmII. This is particularly referring to the IP headers and other traffic pattern identifying information, such as direction or number of packets involved in a communication session in the context of broadband services. So, as a result of the introduction of IPv4 v6 interworking scenarios to the service provider's environment, service providers are faced with a technical challenge to report CACmII in this new and improved way. The challenge is to best restore and report the CACmII to reflect the original traffic characteristics, which are often altered or hidden by the transition mechanisms such as tunneling or network address translation. This presentation follows a logic flow of presenting a problem statement, proposed solutions, and open questions to provide an impact analysis of these transition mechanisms on the reporting of CACmII. The goal of the presentation, instead of reaching to a conclusion, is to stimulate the effective brainstorming on the topic, because this is a rather new controversial area that we need to discuss when it comes to Lawful Intercept. The 2 transition mechanisms we're going to be talking about is integrated DNS64 and NAT64, which is a purely network-based translation mechanism. The other is called DS-Lite, which is a combination of simple IP and IP tunneling and a network-based translation mechanism. Both are standardized by ETF. They both came out quite recently, and they continue to develop. So analysis of their impact on the lawful intercept is a rather new topic. This is a diagram that shows how NAT64 works and how NAT64 allows the communication between IPv6 only endpoint to talk to IPv4 only input on the right-hand side. This is a very simplified flow that how the communication will take place in a broadband service provider environment. The IPv6 endpoint on the left side tries to access the IPv4 only endpoint on the right side. The traffic enters the broadband core of the service provider via an edge device, and this is where we define as the intercept access point, which is also where we capture the data for the target. The traffic also exits the broadband core of the service provider via another edge device, which is another intercept access point where we capture the target traffic. In good old days, as we can see over here, the lawful intercept model is end-to-end. It's directly end-to-end from the left to right-hand side. What we can capture from both intercept access points are already the original traffic identifying information of the targets. But that's not going to work anymore if we don't do any magic when the NAT64 and DNS64 are deployed in the network path. Those are two new elements that are deployed in the network path to disrupt the original end-to-end lawful intercept model. Firstly, as you can see, as shown in step 1 and 2, the DNS modifies the original IPv4 address by prepending a IPv6 prefix to point to the translator. Secondly, as shown in the interface number 3, the translator of NAT64 translates the original IPv6 address to the IPv4 address out of its own address pool. So both operations modifies the original target identifying information, in this case IP headers, which makes the data captured from the IAPs are not accurate anymore. This leads to the problem statement number 1. What's marked in red found in this table shows the data that we captured from the IAP after NAT64 is introduced in the network path. If we pass such data directly as is to the law enforcement agencies, it wouldn't be of interest to them because they're not accurate anymore. They are being modified by the DNS and NAT64 sitting in the network path. Problem statement number 2 refers to the problem that intuitively NAT64 allows two communicating parties with different IP versions to talk to each other. So what's required to be reported in the CACmII message should be able to involve both IP versions. Unfortunately, that behavior is not allowed by the current standard. So if you refer to the ADIS T1IAS standard, which is the implementation guideline for lawful intercept for broadband services, this behavior is not allowed. It only allows the message, the IP headers of the same IP version to be reported in the CACmII message. After identifying two problem statements, what could be the proposed solution to resolve those problems identified? We have two options we can talk about. Option 1 is IACP, do extra magic to resolve the problems. And we can see they're quite intuitive. Number 1, when we say DNS changes the original IPv4 address by prepending some IPv6 prefix, then we can just remove that prefix to restore the IPv4 address. That's intuitive. Number 2, we say the NAT64 translator translates the original v6 to v4 address out of its own address pool, then let's restore it by tracing back the IPv6 address from the translated IPv4 address, of course given a source port and timestamp by consulting the translation table or logs. So that's intuitive too. And when it comes to the last problem statement, when we say reporting both IP versions are not allowed by the standard, then what we can do is we just need to represent one IP version in another address format. In this case, what we can do is we can represent the IPv4 address in the IPv6 address format, so both IP headers remain in the same IP version. Option 2 is we can push the responsibility off to law enforcement agencies. They will do the similar job. The only difference is that responsibility is performed by the LIAS, not the service provider's domain, which is a dream, which is ideal situation from the service provider point of view. What LIAS can do is it can do the exactly same job, restoring the original IPv4 address by removing the IPv6 prefix by themselves. Of course, the last option that we're not listing here is we can propose the standard revision to the standard bodies to handle such interworking scenario, just to allow the message to carry IP headers of both versions. So in that case, it requires the service provider community to be the ultimate proactive driving force of the standard revisions. While the proposed solutions seemed very intuitive, there were open questions that may be worth consideration. Are those proposed solutions good enough solutions to resolve the problem? Number one question that we're faced with is the IPv4 mapped IPv6 address understood by LIAS. Remember, we're using this IPv6 address format to represent the original IPv4 address just to make the IP versions of both IP headers the same. We just intended to use this IP address format as a generic representation of the IPv4 address. However, this particular address type has its own practical use. If you refer to IETF RFCs, it's solely defined. For IPv6 only application, a dual stack environment to talk to IPv4 node. So if we use this address format and provided that to LIAS, it may be misleading to LIAS because dual stack is not in this particular network scenario. Question number 2, are LIAS willing to restore the IPv4 address by themselves? Throughout the years, our participation in the lawmaking when it comes to Lawful Intercept shows that U.S. federal law enforcement continues to upscope the original 1994 CLIA law. They require more and more responsibility on the service provider community to provide even stronger lawful intercept capability. As a general trend, what we can see is that the LIAS would want the data to be as ready for investigation as available as possible without having to further mediate the data. As an example, they would always prefer the plain text over the encrypted messages, which was not a requirement to begin with. And this new requirement just came out very recently, sometime last year, and federal law enforcement wanted the Congress to pass. So throughout the years, what we see, the general trend is to upscope the original CLIA scope, and whether they are willing to take on any mediation responsibility remains a question for us. Open question number 3 refers to the real-time traceback. This is to allow the service provider to restore the original IPv6 address before the translation. And real-time traceback refers to retrieval of the IPv6 address from the translated IPv4 address given a source port and timestamp. It's a very performance-demanding requirement. As you can see, it has to be performed in the real-time fashion. Also, the data that requires to be logged in the translator is humongous because not only the target translation logs should be logged, all the translation sessions should be logged for that purpose. And the cost involved in that process, whether it's justifiable, is a question. This function is rather new, And it's not generally or readily available from major network equipment vendors, as well as the mediation platform vendors for clear purpose. Thus, there's no test data available to help us determine if the technical complexity and the latency, possible latency involved in this process is justifiable. So even though we know it's very intuitive that we can trace back to the original IPv6 address, but can we do that? Can we do that with a reasonable cost? So after I analyze the NAT64 problem statement and proposed solution and open questions, that wraps up the discussion for NAT64. The second transition mechanism we're going to be talking about is called DS-Lite. To put it in simple words, DS-Lite is a combination of simple IP-in-IP tunneling and NAT, network-based address translation NAT44. The only delta that we're talking about here when it compares to the NAT64 is the IPv4 and IPv6 software, which is the tunneling. That is showing interface number 2 on this diagram. This tunneling initiates from the CPE of the access network and terminates on a network-based translator, AFTR, and that is the terminating point of the tunnel. So as you can see over here, the impact of DS-Lite is twofold. One is caused by the tunneling, the other is caused by the network-based translation, network translation. What's worth noting here also is that the communication initiator at the top of the diagram is private IPv4 individual. It's an individual that is private sitting behind a customer network. So typically this could be a small business or enterprise environment, in which case the private endpoints are not known, generally not known to the service provider. Only the public IPv6 address assigned to the CPE is known to the service provider. And what you can see there is the CPE is assigned with IPv6 address, and that's normally used to target the private endpoints from the LIA. As we talked before, the impact of DS-Lite is twofold. Number one is caused by the IP-in-IP tunneling. The original private IPv4 packet is of course encapsulated in the IPv6 tunneling, and the original data IP headers are hidden inside that tunnel. The second is caused by the NAT44. This is exactly the same problem that we are faced in the NAT64. So it's exactly the same scenario over there. Similarly, what we put in the red font is what's captured on the IAPs after the DS-Lite is introduced in the network path. If we pass this data directly as is to the LIA, it wouldn't be of interest because it's already modified. And LIA wouldn't be able to make sense out of it because it's not the original target identifying information. What do we do to address these two problem statements? Similarly, we have multiple options. And hopefully they are intuitive as we did for NAT64. Okay, so we say the original IPv4 packet is encapsulated in the IPv6 wrapper. What do? We can remove that, we can decapsulate the IPv6 wrapper and to restore the original IPv4 packet. So what you see here is we just remove the outer wrapper and report the inner IPv4 headers in the CACmII message to the LIA. Option 2 is we do a little fancy magic here. Instead of simply removing the IPv6 wrapper, what we do is we generate the CACmII message based on combination of inner and outer IP headers of the captured packet. For the IPv6 source address reported in the CACmII, what we use is the tunnel endpoint IPv6 address. This is because what explained in the diagram, that's the only public IPv6 address known and visible to service provider in a business service environment. Of course, the IPv6 destination address reported in the CACmII remains the original IPv4 address, represented in this IPv4 map to IPv6 address. The purpose of doing so is, if you recall what we did in NAT64, we want to represent IPv4 in IPv6 address format to make the both headers in the same IP version. Hopefully that looked or seemed intuitive as well. We can also talk about open questions that's worth consideration. Number one is exactly what we talked about in NAT64. To restore or to trace back the private IPv4 address prior to the translation requires the real-time traceback. So that's a logging function which is not yet available and performance demanding feature, and we're not able to justify the high cost and the latency involved in that complicated process because we don't have test data or working scenario to test out that scenario. Number two, remember what we did in option 1 is to remove the IPv6 outer wrapper to reveal the original IPv4 packet. And remember that IPv4 packet is private. Is reporting IP headers for private endpoints required by CLIA? Normally, the private endpoints in a private customer network remains transparent to the service provider. Customer networks manages their own private endpoints. Those IP addresses and how the IP addresses are being used by their private endpoints are totally transparent to the service provider as well as to the law enforcement agencies. So are we reporting IP headers for private endpoints really is what we wanted to do? Secondly, will reporting of IPv4 address lead to confusion when the subject is targeted by IPv6 address? Remember, IPv6 address is really what's public, what's visible to service provider and law enforcement agencies. And if we deliver IPv4 private IP addresses when the target is targeted by IPv6, will that be misleading? Number three, what we did in option 2, remember, is to generate the fancy CACmII message based on combination of v4 and v6 headers. And that's a relatively more complex mediation process. And the cost associated with that mediation process, is it justifiable? Of course, we're faced with the similar question or challenge as we talked about the NAT64. By using that IPv6 address format to represent the IPv4 address is really understood by the LIA. So we just went through the DS-Lite workflow, the problem statement that's caused by DS-Lite, proposed the solutions and open questions. That wraps up the lawful intercept impact analysis related to DS-Lite. Just as a refresh, DS-Lite, the only delta between DS-Lite and NAT64 is just the simple IP tunneling introduced by DS-Lite, and that's the only delta we're talking about here. Regarding the impacts introduced by the network-based NAT, both transition mechanisms, they share the same aspects. And hopefully that help us keep the problems as simple as we would like to. This presentation only talks about 2 transition mechanisms. Of course, there were other many who are popular as well and who are being deployed by service providers throughout the world. As transition mechanisms are widely being deployed to accommodate the coexistence of IPv4 and IPv6, one goal that service providers will be trying to achieve is to provide the lawful intercept capabilities along with that are as transition technology agnostic as possible. So what I mean here is, regardless of the transitional technology that you are deploying in your network, hopefully the lawful intercept capability remains transparent to that. The final outcome of your lawful intercept capability should be able to achieve the reporting of CACmII and other required data to reflect the original, the most accurate target identifying information as possible. To achieve that goal, the law enforcement agencies should be working with the industry to reach a middle ground between what information is required to be reported and what can be achieved by the technology within reasonable cost. We can do all the fancy magics that we would like to do, but cost is always a constraint on any technology solutions. Any technology solution has to make technical sense as well as the business sense. Another possible outcomes from such kind of discussion, hopefully, it also drives and provides the valuable input to the standard bodies when it comes to lawful intercept. And that includes standard bodies like SE or ADIS for North America, etc. Because those standard bodies are served as the ultimate lawful intercept implementation guidelines to the industry. And once the industry has a universal or agreed upon implementation guidelines when it comes to lawful intercept, there will be no confusion, there will be no debate, and there will be a one unified implementation guideline to go forward. And that wraps up my presentation today. Thank you very much.
Any questions from the audience?
Hi, Bobak Pazdar, Bat Blue. How does this infrastructure and mechanism compare to the warrantless illegal wiretapping that AT&T is doing on U.S. citizens?
It's a very interesting question. I'm working for Chief Security Office, and to be honest with all of the audience here, I'm not aware of any illegal per se intercept that we're launching out against our customers. All the wiretapping has to be lawfully authorized by court orders, and the launching point of a whole lawful intercept process has to be initiated by the issue and the receipt of the lawful authorized orders from a court order investigation. So service provider is not in a position to launch such a process by ourselves. That's illegal by itself. I don't know if that's convincible, but
yeah, you're good.
Familiar with Mark Klein?
No.
Thanks. Thank you.
Thank you.
Hey, Dave. Sorry, I got trapped in the back corner.
Sure.
Just a quick question. I was sort of confused by. Sorry, I'm Chris. I work for Google. And I used to do this CALIA stuff at my last job. In fact, I did every court order we did for 4 straight years and deployed the CALIA infrastructure for the company. So I have a little question. I'm not exactly sure how v4 or v6 either really matters in the case of CALIA intercept. You essentially tell the edge device, in most deployments, you tell the edge device, this subscriber needs to go over the, right? You don't really, that's about all, right? You copy all their packets and ship them to the mediation device and off to the law enforcement person who asked. So that the form of that ends up being, in some cases, this IP address needs to go over there. So with this IP address and this IPv6 address goes over there. I'm confused by how the transition technology really makes any difference. You're just going to tell it a form. And maybe the problem is that your mediation device that initiates the configuration on the edge device for you isn't smart enough to understand anything more than a /32 in v4 land, and you're kind of lucky if it actually knows that, right?
You're correct in terms of the mediation device should be able to apply any additional mediation requirements as necessary to overcome the confusion, like the alteration or the hidden by the tunnel sort of confusion that we just talked about, to reflect or restore the original traffic identifying information. That's the job that IASP has to do.
I guess, but the ISP is going to say this customer, which equals this IP address, needs to get mediated, right? And I think Fred Baker's here somewhere, and he did a bunch of the Cisco side work. If he's in the room, maybe he would hop up to the mic and answer a question, which is, it understands v4, it should understand v6, it's just doing an access list function, so like, is that how it works, Fred? Where's Fred?
He has no problem understanding IPv4 and IPv6, but the problem is that IPv4 and IPv6 captured by the mediation device really is the original or the real customer identifying information we need to report in the CACmII. Suppose it's not, because it's changed by the transitional mechanism, for example, it's changed by the translator sitting in the network path, then the mediation device needs to do extra work to restore the original identifying information.
Okay, it needs to
Right.
strip off a header, right? I mean,
Exactly,
I
exactly.
guess
If that's the work that
this
needs
is
to
a
be
big long
done.
presentation to say we need to do mediation. Great. We do that today already, right? I guess.
Yes, but we have new mediation requirements imposed on the mediation device to accommodate the interworking scenarios. Basically, that's what I would like to
Maybe
say.
Elaine knows the Juniper side answer.
No, actually, but I have questions some are related to this.
Yeah.
Why don't you simply take the layer 2? I'm Alain Durand from Juniper Networks. Why are you not taking simply all the layer 2 data and sending this to the LEA?
Because they're possibly altered or changed by the transitional mechanisms. If we pass that data as is, as we talked in the presentation, to the requesting layers, it wouldn't be making sense to them.
Well, that's a problem, no?
That's the problem. That's the problem we're trying to resolve from the service provider perspective.
My question is, why do you do this? Why don't you simply tell the LEA, go figure it out?
That we sort of touch based in the presentation as well. As a general trend, based on our observation, is that the government is pushing more and more the responsibility onto the service provider's shoulder instead of doing stuff on themselves. They used to invest millions and millions of dollars to develop decryption software by their own, just to decrypt the encrypted content from the service provider, but that's not true anymore. Like we mentioned, the example we mentioned in this presentation, last year the federal government is proposing a law. They want the Congress to pass a law to impose that decryption requirement onto the service provider itself. So they're not even doing that themselves. The trend shows that they are pushing the responsibility of lawful intercept to the industry more and more. That's why service provider needs to investigate the mechanisms that we need, or new requirements we need to take care of to accommodate the interworking scenarios.
So we're going to take 2 more questions. Marty, 1 second.
Chris Donnelly, Cable Labs. I think part of this also depends on which side of your NAT device you do your lawful intercept. So if you do it on the inside of the NAT device, then the headers haven't been changed yet, and you can report exactly what's coming out of your edge device. Whereas if you do it on the outside, then, as you say, you do have to account for the translation.
Exactly, you're correct. You're correct.
Marty?
With regards to pushing more requirements on the providers, this is all done at on a cost recovery basis, isn't it? If I'm correct, can you confirm that?
Can you repeat that? I'm sorry.
This is all you're operating. You're meeting these requirements on a cost recovery basis, correct? So when you talk about the government pushing more requirements on you, you don't mean that they're asking you for things outside the act, that they're just asking you to do more work, correct?
Yeah, exactly.
And it's on a cost recovery basis, correct?
Exactly, that's correct.
Thank you.
They're not making, I mean, they are proposing changes to the law itself, but we haven't been seeing that's officially become enacted as amendment, for example, to the original 1994 CLIA Act. But they keep proposing the new requirements when it comes to law intercept, and they keep asking the Congress to pass them into law. That's what we observed throughout the years.
Thank you.
Thank you.